One last thing to talk about as we wrap up our unit on quadratic equations and functions. We want to talk about how to solve a system of quadratic and linear equations. We spent a whole unit on systems of linear equations, so this is just going to kind of be a review of all that, except we're going to throw in a quadratic equation with that. So let's just discuss what we have when we have a system of quadratic and linear equations. So know that we have a possibility of three solution types. Either we're going to have two solutions because a line can intersect a parabola at 2 points, such as this example. We could have one solution if the line intersects the parabola at its vertex, or there could be no solutions if the line does not intersect the parabola at all. So it's a little bit different than a solution of linear equations. We had three solution types there. Either one, none, or infinitely many. So here know that, understand if I've got an equation for a line, it could cross a parabola at either two places, one, or none. So keep that in mind as you're solving those, as you understand those solution types and how many solutions you should get. So I'd like you to first start off by, just like we did when we solved a system of linear equations, we graph those. We can do the same with a system of quadratic and linear equations. So why don't you graph both of these equations and pause the video and then restart it when you're ready to see the solution. So go ahead. So as we take a look at these graphs, first of all, I graphed y equals negative x plus 1. It's in slope-intercept form, so my y-intercept is a 1. And the slope is negative 1, so I went down 1 over 1, plotted those points out, connected my line. Next, I graphed the quadratic equation. Since it's in standard form, I found my axis of symmetry. It's negative b over 2a, so negative 1 over 2 times 1 is negative half. Then I substituted to find my vertex, negative half. Plugged that into the equation, got negative 2.75, or negative 2 3/4. So then I found other points. I knew my y-intercept would be negative 2. I could reflect that across. And then I just found other points. Plugged 1 in, I got 0. Plugged 2 in, I got 4. Then I could reflect those points across my axis of symmetry. I found that the point of intersection here is at negative 3, 4, and at 1, 0. So that would be two solutions for that graph. Just like we learned elimination with our systems of linear equations, we can do the same thing with quadratic as well. So since we have our equations lined up, got my y's lined up, my x's lined up, I can see which variable I can eliminate. Notice that my y values are the same, so I can subtract those two equations to eliminate the y. And in so doing, the y's cancel out, so I'm left with nothing. On the left side of the equation, x squared minus, well, there's no x squareds in this equation, so I just have x squared. And negative 11x minus negative 12x is positive 1x. And then negative 36 minus positive 36 is negative 72. Notice I've got a quadratic equation left over, and it's equal to 0. So there's multiple ways to solve this. I could either factor it. I could use the quadratic formula. I could complete the square, or I could graph it now. So I have to decide which of these methods I'm going to use for this problem in order to solve for x. And then once I get x, I'll solve, plug it back in, and find y. So I personally, as I look at this problem, I see that I can solve this one by factoring. So I'm going to, since it's a trinomial, I'm going to think of my diamond and think, well, I've got to get factor of negative 72 and a sum of 1. So 9 and negative 8. So I'll say 0 equals x plus 9 times the quantity x minus 8. And then I need to find out what x is. And so x, in order to be equal 8, uses zero product property, so x plus 9 equals 0. Or x minus 8 will equal 0. And when I solve those out, I get x equal to negative 9 or x equals 8. And at this point, now I have to plug those values in and get a y value. So what I'm going to do is just put it into the easier formula. So I'll put it into this one. So y equals negative 12 times negative 9. As I enter that and I add 36, I see y in that case is equal to 144. Plug 8 into this one, so 8 times negative 12. And then I add 36, and I get y is negative 60. So I've got two solutions, and my two solutions are negative 9, 144, or 8, negative 60. And I would have got those same by doing the quadratic formula, completing the square, or graphing just as well. And also keep in mind, if I would have plugged those x values into my quadratic equation, I would get the same corresponding y values as well. And then another, and I believe the final one we'll take a look at today, is the substitution method, which you should be familiar with as well. So remember, substitution, we're trying to find with my two equations, find one of the equations, solve for the variable y or x. Notice this one, I know what y equals. So I'm just going to take this part and substitute it in for that y, since I know what y represents. And I'll rewrite my equation. X squared minus 6x plus 9 goes in for y. And then I finish up the rest of the equation. Plus x equals 5. Combine like terms. X squared minus 6x plus x is minus 5x. Plus 9 equals 5. And now, since it's a quadratic equation, I want to see if I can get that equal to 0. So I'll subtract 5 from both sides. And that'll leave me with x squared minus 5x plus 4 equals 0. And then once again, just like we did with the last problem, since it's a quadratic equation, solve it by any of these methods: factoring, quadratic formula, completing the square, or graphing. This one looks like it can be solved simply by factoring. I need to get a product of 4 and a sum of negative 5. So negative 4 times negative 1 gives me positive 4 and adds up to negative 5. So I'll have x minus 4 times the quantity x minus 1, and that equals 0. So I know x minus 4 equals 0, or x minus 1 equals 0. So notice how all this goes back to solving that quadratic equation. It's kind of the base of everything we're doing here in this systems of quadratic and linear equations. So it's important to know that base stuff because we can build off of it here. So x is 4 or x is 1. So if I go back into my equation, I can plug it into either equation and find y. I'm going to put it into the quadratic equation. 4 squared is 16. Minus 6 times 4 is negative 24. So 16 minus 24 plus 9 gives me a value of 1. So when x is 4, y is 1. When x is 1, 1 squared is 1. Minus 6 is negative 5. Plus 9 is 4. It's kind of cool. Kind of interchangeable there. So when x is 4, y is 1. When x is 1, y is 4. And we see how that works. Those work on this one too. 4, or when y is 1, x is 4. When y is 4, x is 1. That equals 5. So our two coordinates are 4, 1 and 1, 4. Now keep in mind in all these examples that we did today, I showed you that they all had two solutions. A good chunk of the time you're going to have two solutions because, as we said, this line can cross the parabola at two spots. But always keep in mind that there might only be one solution because it only crosses at one point, or you might not get a solution when you solve it down either algebraically or make the graph, because the line might not even cross. So you do some practice in class, and if you have any more questions on this, I can help you out then.